So we're gonna go ahead and look at this because we need to make sure we know what's going on first before we just dive deep into arithmetic and geometric stuff. So arithmetic sequence has a common what? A common difference. And we call that the letter D. And then geometric sequence has a common what? We just talked about it. Common ratio. We call that R. So if we were to go through a sequence and we find it has a common difference in it, then it's arithmetic sequence. If we go through a sequence and we find it has a common ratio, then it's geometric. So for example, let's say we had this sequence here. Let's do this plus something simple. Alright, so we have that. If you look at it, you know you're adding 5 to 5 to get 10, and adding 5 to 10 to get 15, and adding 15 to 5 to 15 to get 20, and then so on and so forth. So that had a common ratio, a common difference there. Of 5. So that made it arithmetic because it had a common ratio. So let's also do this another one. Let's say we have so let's say we do this. If you look at it, if you do 10 divided by 2, you get 5. If you do 50 divided by 10, you get 5. So common ratio will be 5 here, but also if you look at it, 2 times 5 gives you 10, 10 times 5 gives you 50, 50 times 5 gives you 250, and then so on and so forth. So that one has a common ratio of 5. So common difference, common ratio. That's the only difference between these two sequences. That's it. So whenever I give you these equations later, or the sequences later on, and I say, tell me which one's geometric, which one's arithmetic, you need to make sure you know. So hopefully you are paying attention to this video and actually understood what I just said there. If you don't understand, call me over. But again, common difference, arithmetic, common ratio, geometric. Alright, so now let's go more into geometric sequence. And let's go to our formula for it. There we go. So this is our wonderful formula. It's about the nth term of a geometric sequence. So in other words, we're trying to find like the 25th term in that sequence, or the 100th term in that sequence. If we're going to do that, if we're going to try to find that specific term, we use this formula. And again, that formula is given to you on the formula sheet you're going to use for the final exam. But here, that's the formula. AN equals A1 times R, n minus 1 power. So n minus 1 is an exponent. It's an exponent. So n minus 1 is an exponent. It's not on the same line as R. It's an exponent. Now with this, everything is pretty much the same thing except for R. So AN is still the last term that term that we're looking for. So we're looking for the 25th term. That's what AN is. Whatever that 25th term is. If we're looking for like the 100th term, AN is that, whatever that number is for the 100th term, that is the 100th term. All right, then we go into A1, and we know again, A1 is still the first term in the sequence. Doesn't change, that didn't change at all. R is still the common ratio. We just talked about that earlier. So R is common ratio. We know how to find that, yada, yada, yada. And then N is still the same thing. It's that number term that we're looking for. So again, if we're looking for the 20th term, N is 20. If we're looking for the 5th term, N is 5. If we're looking for the 2000th term, N is 2000. So whatever number term we're looking for, that is what N is. And then whatever is in that spot, that 20th spot, that is what AN is. Okay, so that's our formula. And then we're now going to get ready to go to an example.